Yellow everybody. Hello all, how you guys are doing? Hopefully you guys can hear me. Please give me a thumbs up if you can hear me, or just say yeah, you can hear me. That'll be awesome. Just want to make sure I'm audible to everyone. Make sure. Okay. I'm audible, so that's amazing. So hello everyone, welcome back to another pre-security stuff we are going towards. Let me make sure on Twitch as well. I know I'm live on YouTube, not sure about Twitch. Okay, yeah, I'm available on Twitch as well. So hello, welcome everyone. Today we'll cover a lot of stuff. So my plan today is, because I have less constraints, we will be completing our last part of the networking fundamentals, extending our network or your network, right? In which we are going to talk about port forwarding, firewall, VPN, and some LAN basic networking basics, right? Which is very practical, I will say. I have touched this before, so I know it's pretty practical. After that, we have more important stuff regarding the web. And the reason why I will say web is important, because a lot of time, a lot of people here are going towards bug bounty. So this, if you have zero clue about web, or if you don't understand like nitty gritty details of some of the things, this will be a helpful thing, because it will also cover certain topics which a lot of people just don't know about, like DNS, HTTP, how things work, what are headers and all those things, which will help you become a better developer, especially in web developer as well. I do it, right? So I know how it is how much important it is to have web development and understanding of HTTP. So with that being said, let's start with our extending your network capabilities. And I will open my Excel draw so you guys can see, right? Okay. Yeah, this is good, right? So now let's talk about port forwarding. Port forwarding is an essential component in connecting applications and services to the internet. Without port forwarding, applications and services such as web servers are only available to devices within the same direct network, right? Within the network itself. For example, let's say if we don't have port forwarding, let's say if you are in a building, right? Really quickly. Let's say if you are in a building. You work for an organization, let's say Microsoft. You are in a building. One place is the executive floor. Other is, let's say, accounting here. This one, let's say, developers, right? And this one, let's say, HR. Nobody cares about. So we have these three, right? And now inside here, you know which floor belongs to the executive, which floor accountant, dev, and HR. But somebody who don't know, right, they will just say, if they are sending a package, they will say, oh, I want to go to Microsoft accounting. They don't know, okay, which floor, which person, and all those things, right? So that is kind of the issue what a packet will face. And that's why it is said, if we don't have proper port forwarding, applications and services such as web servers are only available to devices within the same direct network, which is in the same building. Take the network below as an example. Within this network, the server with an IP address of 192.168.1.10 runs a web server on port 80. Only two other computers on this network will be able to access this. It is known as intranet. So basically, let's say inside your home, right? When, let's say, if you're talking to Google Home through your phone, right? That's the intranet, because that's inside your house, right? Same with, let's say, your security cameras. If you're trying to access them through your computer, all the security cameras that are connected to your router, that's intranet. So these two computers are talking to this server with port 80 open, network 1. If the administrator wanted the website to be accessible to the public using the internet, right, the whole world, they would have to implement port forwarding like in the diagram below. So we have this router. Remember, this is the router here. Oh, you guys can see my video. My apologies, lads, my apologies. You guys can't see. Sorry. I'll just go quickly again. My apologies, I forgot. So what we talked about is port forwarding, right? Port forwarding is an essential component in connecting applications and services to the internet. Without port forwarding, application services such as web servers are only available to the devices within the same network. So as I was mentioning, right, you have a building. You are in this building. This is a Microsoft building, right? And you know there is executive suite, accounts, dev, and HR. So as a developer, if you want to talk to the HR, you know which floor to talk to, right? Which floor to go to talk to them. But somebody from outside, they don't know anybody inside the HR if they want to talk, right? They can just say, okay, Microsoft. The package will, if they're sending a package, they don't know who it should be sent to, what the floor is, and all those stuff, right? That's the issue. So people inside are able to access things, but people from outside don't know anything. And that's the whole idea with port forwarding. If there is a network like below, right? With this network, there is a server with this IP address and runs on port 80. Only the two computers within the network will have access to it. So only the people inside this organization, kind of, right, in the building will have access to the web server. But we want it to be accessible to outside. And this is your router, right? This is the one helping with the traffic. If the administrator wanted the website to be accessible to the public using the internet, they would have to implement port forwarding like in the diagram below. So you see here, router is allowed to talk to the internet, and router has an IP address 82.62.51.70 with port 80 again. Internet, and let's say somebody else with a particular IP, let's say you want to talk to the Facebook one. So router has to allow network coming in from, let's say, this internet packets coming from this network into this guy, and have, if it is coming specifically on port 80, let it go to the web server. If it is coming on different port, depending on the configuration, you'll let you know. With this design, network 2 will now be able to access the web server running on network 1 using the public IP address of network 1, this one. It is easy to confuse port forwarding with the behavior of a firewall, a technology you will come on to discuss in the later task. Firewall is an important thing we'll discuss later. However, at this stage, just understand that port forwarding opens specific port. Recall how packets work. In the comparison, firewalls determine if the traffic can travel across that port. So basically, in nutshell, right, you have this. Idea is in this is your organization. If there is an outside packet, right, or an outside person, they want to talk to someone, they should know whether they have to go on level 1 to talk to HR, 2 on tech, 3 on accounting, or 4 on executive. Like somebody is coming, right, they should know. There should be some kind of forwarding, which gate to go to, right, or which floor to go to. That's what is the idea of port forwarding. Now, what firewall is like whether this person, right, should be allowed to get inside this organization or not. That's the job of a firewall, which we'll see. So what is the name of the device that is used to configure port forwarding? That's your router. And you can actually do it by going on your router. I think it should be 192.168.0.1. That should probably be your IP address. Once you go there, you should be able to see the port forwarding rules. Useful in businesses because a lot of businesses have their, skip the dishes or DoorDash type of things, like online networks, online orders coming in. That's how port forwarding helps with that. A firewall is a device within a network responsible for determining what traffic is allowed to enter and exit. Think of a firewall as a border security for network. An administrator can configure a firewall to permit and deny traffic from entering or exiting a network based on numerous factors such as where the traffic is coming from. So basically whether it is coming from a known IP address or not, right? Or even like if it is coming from a IP address that should not be allowed. For example, I don't want any IP address of China or North Korea coming into my house, right? Has the firewall been told to accept or deny traffic for this specific network or this IP? What is the traffic going to, where the traffic is going to? So if I'm sending, where it is going to, whether it's going to, like for example, if I'm using TikTok, I don't want any data to be sent to any server outside Canada or North America. I can mention those, like I can just mention which all IP addresses should be allowed. What port is the traffic for? So which port, right? Port 80, as we talked about, there are like 5-6 you have to remember. Port 80, 443 are web. There is DNS 53. Then there is FTP SSH, right? If now tomorrow comes and some application wants to have access to port 888, that's sus. You don't deny that. What protocols, right? Again, UDP, TCP, but HTTP, all those other things as well. Firewalls perform packet inspection to determine the transfer of these questions. Determine the answer of these questions. So with Wireshark, right, which we did and we will cover again, Wireshark helps us with these type of tasks to see what actually a firewall is doing. You can do with the Wireshark. Firewalls comes in all shapes and sizes, from dedicated pieces of hardware often found in large networks like businesses that can handle magnitude of data to residential routers like your home, or software such as Snort. Snort is an online beautiful software. I don't know if you guys are into open source or not. Snort is amazing IDS and IPS, so intrusion, open source intrusion prevention, also intrusion detection system, right? You can download, set it up in your system, or you can even contribute to them through their GitHub. Amazing one. When I was actually applying for my master's position, this was one of the topics I was talking to my so-called to-be supervisor to talk about, okay, I want to do. And Talos is the company that owns it. It's open source, but there is a maintenance company, right? Just like Kubernetes is by Google. Same thing. Snort. Firewalls can be categorized into 2 to 5 categories. We'll cover 2 primary firewalls. Stateful, right? So firewall category and description. This type of firewall uses the entire information from a connection rather than inspecting the individual packet. This firewall determines the behavior of a device based upon their entire connection. This firewall type consumes many resources in comparison to stateless firewalls, as the decision, one sec, making sure no messages, okay. This firewall type consumes many resources in comparison to the stateless firewalls, as the decision making is dynamic. For example, a firewall could allow this part of a TCP handshake that would later fail. The firewall type consumes many resources in comparison to stateless firewalls, as the decision making is dynamic. Okay, this one is a dynamic one. For example, so first, if this connection is set up, still the firewall can say, okay, even if the connection was set up, let's say to TikTok server, I am denying it. I don't want this information or this type of connection or packets going through. If a connection from a host is bad, it will block the entire device using the MAC address, right? It can notice those things. This one, stateless one, this firewall type uses a static set of rules to determine whether or not individual packets are acceptable or not. So that's the difference, right? Stateful ones are more dynamic, they are better. Stateless ones are like, let's say you have set up 5 instructions. If they follow them, good enough. For example, a device sending a bad packet will not necessarily mean that the entire device is blocked, just let's say certain packets by that device. Whilst these firewalls are use much fewer resources than the alternative, they are much dumber. For example, these firewalls are only effective as the rules that are defined within them. So if you define good rules, good stuff. If not, bye-bye or get hacked. If a rule is not exactly the method, it is efficiently useless. However, these firewalls are great when receiving large amount of traffic from a set of hosts, such as distributed denial service attacks. So basically, let's say if I create a AWS network, right, a AWS server, and I start sending DDoS attack, this will be helpful in blocking a bunch of them without, in case of stateful one, it will try to set up a TCP handshake, right? This one will directly will block all of that. What layer of the OSI model do firewalls operate at? For this example, just provide the numbers in ascending order separately and ampersand, right? So separated by ampersand. So firewalls OSI model, right? I will say they will be in level 1 is data link, don't need it. MAC 3 and 4 will be one transmission and networking, right? So my idea will be 3 and 4. Cool. Well, after that, this presentation session, you don't need those, right? It's all about like packets and networking. What category of firewall inspects the entire connection? Stateful or stateless? So I think this one will be stateful because it is looking through all the packets and dynamic thing, right? What category of firewall inspects individual packets? This is again stateful because it's looking through all the stuff. No, stateless. Inspect individual packets. Oh, rather than inspecting. Sorry. This one is not individual packet. Okay. My apologies. Practical firewall task. Deploy the static website attached to this. Malicious traffic are marked as the packets in red. The legitimate traffics are the packets marked green. The protocol you need to block is port 80. Configure the firewall to prevent the malicious packets from reaching the server. Web server is this, right? So that's our task. What I will do, I will quickly hide my face for a second so you guys can see what's going on, right? Okay, probably you can't see me now. And let's see. This website at this IP address is under attack. Let's copy this IP. Quickly add some firewall rules to stop the server from crashing. The packet in red are the attackers one. Start simulation. So we have the source IP and destination IP port. So we have to set up a rule, right? Drop, pass, port and stuff. So we have this and we know this is a web server. What we have to do is crashed almost, right? With so many sending. What we have to do, I have to do it quickly. So I need to do 198.51. Destination should be our IP. This one, right? Port 80, drop. Let's see. So now you can see the router is only allowing the traffic from a genuine connection. Let me make this. Now you should be able to see. Let me redo again. I'll redo it quickly for you guys to see because I think you didn't see it properly last time. Okay. So we are first we know the red one is the wrong IP, like the malicious one. So put that. Destination IP should be R1, our web server. Port should be 80. So we drop this. And as you can see, this one, the below one here, this guy is the genuine connection. That's why it's green. And we are able to say, and here you can see how much the server packets are receiving, how much it is clogged and resources are being used. So hopefully that makes sense. That's actually a nice quick way to show. That's a good one. Okay. Now we can close this. Let's talk about VPN. VPN, this is actually everybody might have used it, and I can actually give you a quick idea. If you don't like paying for VPN, but you want your data to be secure, you can use something like a Raspberry Pi to go through these. But let's go over like what VPN is first. A virtual private network, right? A VPN for short is a technology that allows devices on separate networks to communicate securely by creating dedicated path between each other over the internet, known as a tunnel. Devices connected within this tunnel form their own private network. What this means, let me give you a beautiful example, right? I don't know if you have seen, right? Let's say there are two buildings, right? Building A and building B. Simple. Multiple floors, blah, 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 right? Building A, you live in building A and your friend lives in building B. And you want to talk to them, right? Let's say if it was a medieval time, like when phones were not a thing. So if you are standing here, right? And if you wanted to chat and you don't want to go down, right? What do? You talk to the person, you call the person out, right? They come to their balcony and they also chat. The thing with this is everyone in the building, right? Let's say if there is a person here, attacker here, the aunties in the house or in the building, right? They all can hear what's going on. Now, instead of this, right? Let's say you did that simple thing, cup and what's this called, wire. If you remember something like this, right? There used to be a cup and wire thing, right? Like this, two people are talking. Imagine instead of talking, shouting so loudly, what you did here, you both got a cup, a simple cup, and you put a wire through it. Now, what you say, only you can hear, nobody else in the world can hear it, right? That's the concept of VPN as well. When you are going, right? Anybody who, let's say, is sharing, let's say if you are sitting in a coffee cafe, right? And like anybody can see, hear, basically by sniffing the network, what you are saying. But if you have a VPN, it adds that extra tunnel, extra encryption, where you are like having a private network to go and talk to the person. And that's how basically VPN works. But in this here, proper VPN, there will be like a moderator, someone who can actually like a VPN server to help you with that, creating that connection, a private connection. That's how VPN works. So let's go over this. And that's why it's called a virtually private network, right? A separate networks to communicate securely by creating a dedicated path, just like you had a dedicated path to talk to each other. For example, only devices within the same network, such as within a device, can directly communicate. However, VPN allows two offices to be connected. Let's take the diagram below where there are three networks. First, we have internet where network 1, 2, 3 is there, right? And then we have network 2 and 3 is basically VPN. These two, this one and these two are connected over the internet, but they act as a third network. Network 1, office 1, 2 and 2 devices connected via, so they are technically not network 1 or this is not in network 2, they are in a private network. That's how it happens with TryHackMe, right? Whenever you are starting, if you're going with your TryHackMe, you set up a proper private connection with OpenVPN. These devices connected on network 3 are still a part of network 1 and 3, but also form together to create a private network that only devices connected to the connected via this VPN can communicate over. The encryption is there. Let's cover some of the other benefits offered by VPN in the table below. Allow networks in a different geographical location to be connected. For example, a business with multiple offices will find VPNs beneficial as it means that resources like servers, infrastructure can be accessed from other office. Basically, let's say if I am in Apple or I am in Microsoft, right? I am sitting in California and I want to talk to somebody in India privately. right? I will use a VPN connection to create that thing and able to access. Just like we have TryHackMe. I'm sitting in Canada. I want to have access to those machines in US or Europe. Offers privacy. VPN network technology uses encryption to protect data, extra layer of protection. This means that it can only be understood between devices it is being sent from and is destined for, meaning the data isn't vulnerable to sniffing like the one I mentioned. If you are using VPN when at a coffee machine, you are good to go. This encryption is useful in places like public Wi-Fi where no encryption is provided by the network. You can use a VPN to protect your traffic from being viewed by other people. Offers anonymity. Journalists, activists depend upon VPNs to safely report on global issues in countries where freedom of speech is controlled. Example, Saudi, there was a project called Project Raven, hunting journalists. Same with Edward Snowden, things like that, right? And you want to use Tor if you are going against a big organization or big people, but VPN also does a good job. Usually your traffic can be viewed by your ISP and other intermediaries and therefore tracked. The level of anonymity a VPN provides is only as much as how other devices on the network respect privacy. For example, a VPN that logs all your data history is essentially same as not using a VPN in this regard. And that's why you need to make sure whenever you're getting a VPN, right? There are a lot of companies that do log your stuff. So it's very important to make sure, and a lot of time you need to make sure you are not using a US company for VPN, I will say, because a lot of them do have log by the government and they have things like that. But there are some, I think, Swedish companies which are pretty good in this. Swedish companies that are pretty good in this. I think this is banned, so never mind. But yeah, like I think if I'm not wrong, Surfshark is a good one. That's why I think I know. But yeah, others, a bunch of them don't do it. Masked Helm, what's up, bro? How you doing? Howdy, howdy. How's your day so far, buddy? So, as we are saying, right, with the VPN, TryHackMe uses VPN to connect to our vulnerable machines without making them directly accessible on the internet. Why it is important? Let's say if somebody before you, let's say you are trying to hack a machine, and it's on the internet, right? A hacker can come, see this is available, hack it, and through them they can hack you, right? Because you're not checking all the traffic, you're trying to hack the machine, that you can be hacked. And that's the whole idea. This should not be accessible to the internet. This means that you can securely interact with your machine or their machine. Services provide such as ISPs don't think you are attacking another machine on the internet, which could be against the terms of service. So let's say, for example, T-Mobile, Shaw, Geo, they can actually like block you. You can be on like FBI wanted list or blacklist. A VPN provides security to TryHackMe as a vulnerable machines are not accessible using the internet. Because somebody can like start using Bitcoin to mine these Bitcoins, right? Masked Helm, are you learning stuff? Like how are you feeling about this stuff? Are you learning about the VPN logs and stuff? Anybody else knew about this? Like a lot of VPN company put a log for you. So it's basically you are paying for nothing. VPN technology has improved over the years. Let's explore some of the existing VPN technologies below. But if you want to be anonymous, Tor is always a preferred one with PGP or a security like PGP. Pretty good privacy. That's the full form. So VPN technology and their description. There is PPP. This technology is used by PPTP, explained below, to allow for authentication and provides encryption of data. VPNs work by using a private key and public certificate, similar to SSH. A private key and certificate must match for you to connect. This technology is not capable of leaving a network by itself, not routable. Okay, this is not routable. Okay, interesting. PPTP, point-to-point tunneling protocol. is the technology that allows the data from PPP to travel and leave a network. Okay, they work on top of each other. PPTP is a very easy to set up and is supported by most devices. It is, however, weakly encrypted in comparison to alternative. Interesting thing I will tell you, right? Let's say if you're using not a router given to you by your company, but let's say a ASUS router, right? These type of router, which are like around $100, right? They have their own FTP and all those things. What you can do, you can use, I think, DD our router. There is a router VPN software which is on available for free. WireGuard, maybe? No. There is another one. I forgot the name. But what you can do, if you buy a router like this, right? You technically don't need a VPN. You set up your router with that encryption, and it will like help you with the extra level of security on top of it. IPsec, Internet Protocol Security. IPsec encrypts data using existing Internet Protocol framework. IPsec is difficult to set up in comparison to alternatives. However, it is successful. If successful, it boosts strong encryption and is also supported on many devices. I'm actually curious. Router VPN softwares open source. I think it might be WireGuard, or even you can use OpenVPN to have it on your router and set it up. For home servers, right? You can to have a home server. Good, because let's say if you want to send magic packet to turn on your computer from anywhere in the world, these things are very helpful. What VPN technology only encrypts and provides authentication for data? The first one, right? PPP. The one that uses IP framework, IPsec. This is just a good knowledge as of now, I will say, because I don't think you will need it for PT1. I don't feel like you will need it. In PT1 is more of if you are able to hack and use this thing. But if you have like a Raspberry Pi at home, I don't know if you guys do it. Not retro, for retro game. This is, yeah. So you can build your own VPN, Pi VPN, right? To set up and make sure your network is safe. Whereas instead of connecting to router, you will be connecting through your VPN or Pi. Okay, what is a router? It's a router's job to connect networks and pass data between them. Router, think of it as a mailman or a post office, right? They are helping you connect to the world to help your traffic, your packets to route between different servers. So that's the job of a router, just like a postman. It does it using routing, hence the name router. Routing is the label given to the process of traveling across the network, just like your packets, your envelopes, your whatever parcels you want to send, right? Routing involves creating a path between networks so that this data can be successfully delivered. Routers operate at level 3 of the OSI model. The level 3 is the network model, networking layer, which has, like, I believe that one was the one with IP, right? They often feature an interactive interface such as a website or a console that allows an administrator to configure various rules such as port forwarding or firewalling. If you have a router at home, right? Go look below. There you will see a IP address, and if you go to your browser and type that IP address, probably it will be 192.168.1.0.1, probably, right? Or 1.1. You will be able to access your router and see what's going on. That is used, like, if you want to make sure your kids are not using any adult sites, you can block those from there. Routing is useful when devices are connected by many paths, such as in the example diagram below, where the most optimal path is taken. basically the fastest way, like your Amazon's Prime delivery. Routers are dedicated services and do not perform the same functions as switches. We can see the computer A's network right here connected to computer B's network by two routers in the middle. The question is, what path will be taken? Different protocols will decide what path should be taken, but factors include basically what this means. There are different protocols, right, to find the best path. Some give weightage of one criteria over others. Some will look at, okay, what is the shortest path? They will give that a better, higher rank. But some will be like, okay, I want to make sure which one is the most reliable one and which one is the most fastest medium, copper, optic fiber, and all those stuff, right? So depending on which protocol you're using. And it's good to know a little bit about them, but do not go in depth because people do PhD in those type of things. And the word you are looking for is, I think, gateway bridge border gateway protocol. That one is some people I know one person who has done his PhD in this. So just know what things are, but don't go super big into it. You won't need it for your certification. What is a switch? A switch is a dedicated networking device responsible for providing a means of connecting to multiple devices. Switches can facilitate many devices from 3 to 63 using Ethernet cable. Why not 4 or 64? Because one will be the connection to the internet itself, right? Switches can operate at both level 2 and 3 of the OSI model, because it will be like, sending IP addresses and all that connection, but also MAC addresses. However, these are exclusive in the sense that layer 2 switches cannot operate at layer 3. Take, for example, a layer 2 switch in the diagram below. These switches will forward frames. Remember, these are no longer packets as the IP protocol has been stripped. Remember the thing I mentioned? I'll do a quick one. When you are sending, right, data, encapsulation happens, right? Let's say it's your data here. That's layer 1. Layer 2 comes, puts MAC address and all the other information. This green one is a frame now. After this becomes, with the IP protocol added, this becomes layer 3. This one is layer 2, right? Now, if I remove, and this layer 3 is called a frame, this one is called a packet. What this router, a switch, basically at layer 2 will do, it will take care of, it will only be able to handle data that looks like this. It won't be taking care of the blue part, whereas a router will be. These switches are solely responsible for sending frames to the correct device. So router is sending data to layer 2 and is sending to whichever device it should be sent to. Now let's move on to layer 3 switches. These switches are more sophisticated than layer 2 as they can perform some of the responsibilities of a router. Namely, these switches will send frames to devices as layer 2 does, and route packets to other devices using the IP protocol. What that means? These type of routers will be able to take care of this, plus also the one which has data. Both type of this, right? This one is a frame now. So it will be able to take care of this as well as this type of information. Let's take a look at the diagram below of a layer 3 switch in action. We can see that there are two IP addresses. One is basically 192.168.192.168.1.1 and 2.1. A technology called VLAN, Virtual Local Area Network, allows specific devices within a network to be virtually split up. This split means they can all benefit from using things such as internet connection, but are treated separately. This network separation provides security because it means the rules in place determine how traffic or how specific devices communicate with each other. This segregation is illustrated. So why would you need this? Any idea? Why would you need this, right? So I don't know if you know a company like WeWork. If you see, there is one sales department and accountant department, right? But let's say I will give you a better example, which is way more practical, right? Let's say you work, your company is working at WeWork, and this was actually an issue. They didn't take care of it, but how they should have is, let's say if there is a router here, blue one. Let's say there is a router here, right? This is how you show a router. Very bad image, but yeah. Let's say there is a router, right? This is the whole internet sending data. Now, a router's job should be based on what it is getting, or basically in this diagram, if it is sending to a switch job should be which floor or which department or which cubicle this should be sent. Should it be sent to organization A, or should it be sent to organization B? Right? That's the job of this switch, layer 3 switch. Good, even let's say if not organization but department A, department B, all those things. And let me give you an example of, I can find that, I think, WeWork. So WeWork's Wi-Fi exposed files, credentials, emails because their system didn't have these things in place, right? There wasn't security. So one person, what a lot of people did, let's say if I started a company, right? This is a startup. This is my work. And this one is, let's say, Microsoft. And I'm looking at what Microsoft, right, is about to, let's say, which new contract from Pentagon they're about to get, right? Or what clients do they have? So my startup, let's say, working in a similar office type, like office type software, will also approach, can see all the list of the clients here, right? I can look at all their clients, all their bids, and just lowball them by a bid to get those contracts. So that's the issue, and that's why you need these type of devices to separate your network. And if you have like a common, like a WeWork type environment, make sure these things are there, or you can lose everything. In the context of a diagram above, the sales department and accounting department will be able to access the internet, but not able to communicate with each other, although they are connected to the same switch, because it's virtually in different places. It's like almost like, let's say you are in the same building, but it will feel like you are in different buildings or different offices. That's the whole idea. What is the verb for the action that a router does? Verb will be routing, I think. Routing. Yeah. What are the two different layers of switches? Separate by comma, right? So if there is layer X and layer Y, so it will be 2 and 3. Layer 2 for the MAC addresses and stuff. Layer 3 for IP addresses. Right? Now let's talk about a practical simulation. Deploy the static website site attached to this network and experiment with the network simulator. The simulator will break down every step a packet needs to take to get from A to B. Try sending a TCP packet from computer 1 to 3 to reveal a flag. Please use the Chrome or Firefox for this. Okay. Do not use Internet Explorer ads. Okay. Cool. I will hide myself again. Probably that would be needed. For this one, right? So as you can see, there is computer 1 here. There's computer 1 switch and computer 2. Then we have a router again switch 2 and computer 3, and we have different ledgers, I guess, or basically what color belongs to which type of packet. TCP packet, handshake packet, UDP packet, ARP packet, and ping. Ping is to just see if that device are able to connect, right? Our job will break down every step of the packet. So we have to send TCP packet from computer 1 to 3 to reveal a flag. Now, if we directly do, I believe maybe first we have to send a handshake packet. So let's say if I send data 1, it sends to all the switches, sends everywhere, right, to know which IP address is going. And now it goes to the router, it knows it's in the internet. Switch 2 goes here to packet 3. Handshake is happening. Now the acknowledgement, ARP response. Now the TCP packet is going over, right? And is sending the handshake packet again. Basically saying you have got the data. Cool. Now let's look at the logs on the bottom left that were going on. So let's see what this one said, right? Starting from bottom. Computer 3 received TCP packet. No, starting from top. So first we do the handshake between the computer 1 and 3. Then computer 1 sends a synchronized packet. The next one, computer 1 says, computer 3 is not in my local network, sending it to the world, to the internet, right? Then ARP request who has the router tell computer 1. So basically first computer 1 sends to switch. Switch says, okay, I will send everywhere. This one is not the one, so drops it. Router says, okay, this is not available in our system, this IP address. I'll send it to the whole world, but also tells computer 1 that this is happening. Then this reaches this switch, and switch 1 sends to computer 3. Computer 3 says, okay, yes. So that's where this is happening. Hey, computer 1, I'm the router. Who has computer 3 tell router. So they are setting up the MAC addresses and local IP addresses. I'm computer 3. Now handshake begins. Computer 3 received sync packet from computer 1, right, and sends the sync and acknowledge packet. So it goes here, switch 2 sends that. Computer 1 received the sync and acknowledge packet from computer 3, sending the acknowledge. So remember, sync and acknowledge, and then the TCP packet, our main bread and butter, is sent to computer 3. Computer 3 says, hey, I have received it. I'm acknowledging I've received your packet. That's it. So if you see, same thing. Now it directly can send it. It is directly sending because it knows where is the computer. It doesn't have to do the handshake anymore. But what if computer 2 wants to send it to computer 3? Let's see. Okay. Computer 3 sends it, right? It gets the router, says, yeah, this person is not available, goes to the internet. Computer 3 receives as acknowledgement, right? And the last acknowledgement, sync and acknowledge, and now the actual data is being sent. And now it says, okay, I've received it, and we will see our flag. Or maybe we are not seeing our flag because it's computer 2. Never mind. Yeah, we won't see our flag. Only for computer 1. But yeah, hopefully you guys got that. So how many handshake entries are there in the network log? I think is the router one. Should we count? Oh. Handshake 1. Routing ARP. First handshake between 1 and 3. There should be 3 total, right? Should be 3. That's it. Let's see if this works. Nope. Okay. So we have the router ones I have to talk about too. So we have 1, 2, 3, 4, 5. Why 5? Because router, we have to have a handshake with the router, I believe. Received acknowledgement from computer 1. Received and sync. Computer C sends the sync 1. Computer 1 and 3. Starting the IP handshake. Yeah, that's probably good. If it is not giving error, that's probably good. Hopefully you guys understood that one. Let's see if this one gets it in. Yep. Okay. We cleared our stuff. Now let's go to our, I closed it accidentally. Beautiful. Now let's go back to our PreSecurity and see how the web works. So we completed all our networking fundamentals one, introduction to cybersecurity. Now let's look at how the web works. DNS in detail. What is DNS? DNS, the domain name system. Easiest way I can explain you this thing. Easiest you will ever find, because this is way too you have seen, right? When you have your phone and you want to call someone, what do? You pick up your phone, you type their name, right? And then you see the name with the phone number here. That's what DNS is. Because you are not remembering their number, right? You're not remembering their number. Make it better. Yeah, you're not remembering their number, you're remembering their name, right? And that's what you are searching. That's the whole idea with the internet. You are not searching for the IP address of Google, right? You don't know it is 888 or it could be 202020, right? They have so many. What you do, you look for google.com. And just like in your phone, just like a directory, right? You type the name, there's a phone number attached to it. The DNS server has the same idea, right? Like a caller, basically your directory, in which there is the URL, also known as the domain name, right? Domain name, and their IP address of their server. So you type google.com, whatever is the IP, you will get that back as a user. That's how the whole internet works. That's called domain name system. So domain name system provides a simple way for us to communicate with devices on the internet without remembering complex numbers, their IP addresses. Much like every house has a unique address for sending mail directly to them, every computer on the internet has its own unique address. You don't remember everyone's address, right? You just remember their name or their phone number. You don't remember their phone number. And the address of a computer on the internet is called IP address. An IP address looks like this. 4 numbers together. 4 sets of digits ranging from 0 to 255 separated by a period. When you want to visit a website, that's not exactly convenient to remember this complicated set of numbers, and that's where DNS can help. So instead of remembering this, you can remember TryHackMe. So let's check this out actually. So if I go here, direct IP access is not allowed. Why? It should be allowed. Give me that. HTTP. Nope. Okay. So they have blocked they have blocked like anyone's IP address. You can't access directly. You have to go through the DNS of Cloudflare. Okay, which is fine. So basically, tryhackme.com is this. One thing we actually can do though, copy link address. I can see Google DNS. Public DNS. No. Query. So dns.google.com. I type the domain name here. Let's see if we get. So we get this and we get. What is the IP address? No, we are just getting this route to this server. Interesting. What if I type google.com, or what if I type like I have IP address of one of the websites because this is my website I do for playing. around. So you see, this is the IP address of my website. Simple. And that's what is going in the background. So let's join this room. What does DNS stand for? Domain Name System. Domain hierarchy. This is a very interesting concept because you can find jobs at companies who is doing this, right? Domain hierarchy. Let me make it a better way for you guys to view. Now I can show you properly. So domain, root domain is the dot. Now top level domain, these are the one you have seen. After dot there is com, edu, government, tech, and nowadays AI is pretty big, right? And then you have second level domain, which will be like google.com, tryhackme.com, mit.edu, right? USA.government, nasa.government, right? Military and stuff. And that's how things work. This is the hierarchy. It's very important to know because this is how your data flows. It first look at, after when you type tryhackme.com or google.com, goes to dot and then .com, and then it looks for Google instead of like google.com and stuff. Probably here. No. Here. So TLD, not TLDR, TLD, top level domain. A top level domain is the most right hand part of the domain name. So for example, TryHackMe's top level domain is .com. There are two types of top level domain: GLD, generic top level, or CCTLD, which is country code. For example, .ca, .uk, .usa, right? Country ones. .in for India. Historically, a GTLD was meant to tell the user the domain name's purpose. For example, a .com is for commercial purpose, like Google. .org, like the one I have, is for organization. .edu is for education. .gov is for government. And you might have seen edu for your schools, and that is what you used for like things like GitHub Student Pack and stuff. As a CCTLD was supposed to be for geographical purpose, like for CA based in Canada and .co.uk for in things inside United Kingdom and so on. Like IN is for India, and a lot of countries, what they do, they say, okay, only Canadian companies can have .ca domain. You have to be registered as a business in Canada to have this. Technically you don't, but a lot of countries do that. Due to such demand, there is an influx of new GTLDs, online, .club, .website, .biz. The most interesting one, in my opinion, is .zip. What a great domain name to have to start hacking, because then if I have .zip, I can say download or Microsoft.zip, people will think, or Office.zip, people will think they're downloading Office update. But reality is they are downloading a software, malware, right? And that's how things work. Second level is the one you usually talk to. Taking tryhackme.com as an example, you remove the top.com, which is the top level one. Secondary is tryhackme. When registering a domain name, the second level domain is limited to 63 characters plus the TLD and can only use A to Z and 0 to 9 and hyphens. Cannot start or end with hyphens or have consecutive hyphens. Subdomain. A subdomain sits on the left hand side of the second level domain. What that means is, let's say I have tryhackme.com. You will have shop. This is the one we are talking about. That is your subdomain, and that's what you use for hacking. You want to see more domains available on TryHackMe, you will go with shop. A lot of companies, for example, let's say Google.com will have drive.google.com. They will have, let's say, more like, instead of drive, they will have Gemini. Oh, Gemini is one, right? Gemini.google.com. Gemini.google.com. So Gemini is a subdomain. I can't show you what I'm researching, but to give you an idea why this is just a funny thing to tell you, if I'm looking for a software, I'm building a software, I have Gemini, I have Perplexity, I have OpenAI, I have all these guys open, and I ask them the same question to get the answer. It's just too awesome. And you can look for which one is producing the best answer. Claude 2. Just this fun thing I want to share. Really interesting to look into. So, as I was saying, a subdomain sits on the left hand side of the second level domain using a period to separate it. For example, in the name admin.tryhackme.com, the admin part is the subdomain. A subdomain has the same criteria restrictions as the second level, 63 characters, right? And blah blah blah, hyphens. You can use multiple subdomains split by periods to create a longer name. So you can have jupiters.servers.tryhackme.com. So you can have 10 different ones, I believe. Length must be kept between 250 characters or less. Okay. There is no limit into the number of subdomains you can create for domain name. Let's see if this is available. No. Okay. But yeah, so basically total length is 253. Maximum length of subdomain 63, a particular one subdomain. Which of the following characters cannot be used? So underscore can't be used, right? What is the maximum length of a domain name? 253. What type of TLD is uk.co.g or ccTLD? Okay. Record types. Let me drink some water. Record types. This, if you are in DevOps, if you are starting your own company, if you want to have your own website, you will use this. So pay attention, and this is very important because this will help you find the email servers of a company. This will help you find other type of servers that that you can probably look or hack for a company through your record types, DNS record types. There are multiple. There are 5 which we use all the time. DNS isn't just for websites though, and multiple types of DNS records exist. We can go over the most common ones. First one is A. This is the IPv4 address. 4 is IPv6 address. Hardly I see this, but CNAME, you see this all the time. This is the name, the domain name one. These records resolve to another domain name. For example, TryHackMe's online subdomain store.tryhackme.com, which returns CNAME shops.shopify.com. Another DNS request will be made to shops.shopify. Here is the interesting thing now. If I go to DNS Google and I type this one, let's see what this resolves to. You see here, store.tryhackme.com basically resolves to shops.myshopify.com, and that's how you know there is a record, a DNS record, and it's telling you, right, the record types and everything. It's going to tell you all the DNS records. This is the open information, and that's why hackers use it. It's easily able to find. MX record, this is a big one. These records resolve addresses for the server that handles the email for the domain you are querying. For example, MX record responses for TryHackMe would look something like this one. Okay, so you know they are probably using either Google's Gmail internally. These records, or Google Drive and Google Workspace. These records are also come with a priority flag. This tells the client in which order to try the servers. This is perfect if the main server goes down and email needs to be sent to a backup server. So for example, let's say Outlook. We had seen last year Outlook was down for some time. If there is one server of Outlook is down, you can send it to second one. Second is down, you send it to third one. Mostly it's the 2. But let's say if I go with TryHackMe, can I see? Record type I want to see is the, where is the MX one? No. So I see CNAME one. I want to see. Okay, now I can see. So MX. You can see there are multiple, but only few are important. Oh, thank you so much. Slovakia. Oh, thank you, bro. God bless you too. Oh, thank you so much. I love that. I love that. Thank you. So yeah, we can see here MX, right? Now let's see TryHackMe's MX1. You see here, Google one server, second server, third server, fourth server, fifth server. And there is a priority to attach to these things. Can I see the priority here? I probably cannot. It's probably in the DNS one, but oh wait. Here is the priority, right? 1, 5, 10. There are 2 5s. Interestingly, so I don't know if 2 5s are allowed. Okay. But yeah, I think like those, there are 2 10s. Okay, so if I ask Google, let's say explain. Let's see Google, what Google says. What AI says for this. Perplexity is a good one. I have a whole command for this. Spaces, hacking. But thank you so much, bro. I love the message. Thank you so much. I can't thank you enough. These things make my day, so thank you so much. Oh, here. I would love to pin this. So let's see. I used DNS Google to find MX record of a website, and I got following response. Help me understand which record has a higher priority and explain the data field as well. And if you want, actually, because I have my hackers.org, right? What AI do you use? Do you want? Actually, I can show you really beautifully. Give me one sec. I'll show you. I'm my maniac. So we were right on the priority one. Mail records are DNS records that specify mail responses, right? Priority, a non-negative integer indicating. So the lower the number, the higher the priority, right? Just like a ranking system. Has the lowest priority, blah, blah, blah. 5 is the priority. How can 2 servers have same priority? Yes, 2 or more mail servers can have priority. Okay. So, brother, to answer your question regarding like which AI I use, my AI, it's very interesting because I use multiple. I saw this Instagram or LinkedIn post where a guy, right, asked question to all the AIs to see which one is producing the best results and use that. And that's what I do. So if you see, I have this tag, right? I have Gemini open. I can't show what I was researching because it's some stuff, but there is Claude. Little bit you guys can see it's for content generation, some SEO stuff I'm doing, but I have OpenAI, Claude, Gemini, Perplexity. I use all of them because what I do is, let's say for example, I'm here, I'll create a prompt. And this is what I saw somebody using this idea. So I just use that. I first ask AI, create a prompt for AI model to do this, right? It will generate a prompt for whatever I'm asking it to do. Then I can even edit it a bit and stuff. Then I use that prompt and enter that into these models. And I create basically a chain of, and because the prompt is generated by AI itself, it's a pretty good detailed prompt. And then that's what I use to like put inside Gemini, I put inside Claude and all those. And my personally, for coding, I love Gemini and Claude. For content creation, for example, images, Ghibli style and even non-Ghibli style, but actually good images, I use GPTs of ChatGPT. And for example, research, I love Perplexity. So hopefully that answers those questions. And that's why, like, for example, if you see, I cannot show you the whole thing, but if you see content creation, automation help. So I used this GPT to help me automate content creation. Does that answer your question? Hopefully it does, right? I have to, actually, interestingly, you mentioned I was looking into Meta to start using Meta's Llama as well. But I will say use all of them, get a feel of how all of them work, and just start playing around. Because if you see here, right, for a business, what I'm doing, I have this. I even use GitHub's Copilot, but again, for that, I either use Claude 4 or Gemini's 2.5 Pro. So those things I use for coding. If you're specifically looking for coding. For content, OpenAI, hands down. Better than Gemini, better than Claude, and stuff. Claude is kind of okay, but it never produces a good one like the way I wanted. Just saying. But OpenAI is really good in this. Does that answer your question? Hopefully. And you guys can tell me what is your purpose you want to use AI for, and probably I can help you finding the right AI for that. And majority of them you don't have to pay. So many of them, just create 2 accounts of each. My whole life for a year, I never had to pay for a very good one. Sora is free now. Why you need to pay for anything, right? Okay. Last but not the least, an interesting one is the TXT record for the DNS. TXT records are free text fields where any text-based data can be stored. TXT records have multiple users, but some common ones can be to list servers that have the authority to send an email on behalf of the domain. This can help in battle against spam and spoofed email. They can also be used to verify ownership of the domain name when signing up for third parties. Very important, this last part, because when I was doing it with Cloudflare, what I had to do is the text I had created, given to me by Cloudflare, I had to put in my Google domains. Now with Square space, I put them in those text records, and that's how you do it. A very beautiful, and I will prefer everyone with so many free resources nowadays. Create your own using AI or using just Google. Create your own website and publish it once. Very major thing, especially with your resume, helps a lot. A great thing to talk about during your resume time. And when you are in an interview, I love talking about my website. I love talking about some crazy thing I did, which is not usually done by other, but it's something cool to do. Like even YouTube channel, right? So if you want any help like those as well, feel free. My Discord is always open, right? So I can just send you my Discord here. I have to add this command to YouTube as well. I keep forgetting. But yeah, this is my Discord. So if anybody is interested, feel free to join. I have a beautiful community. People talk. We share good videos to help each other. So we have here, what type of record would be used to advise where to send the email? Email should be sent using the MX record. What type of record handles IPv6? 4As. Now let's talk about making a request. What happens when you make a DNS request? When you request a domain name, your computer first checks its local cache to see if you have previously looked up the address recently. If not, a request to your recursive DNS server will be made. Here's how things work. Pretty simple, right? Local DNS, I can say, what is the name given to it? Okay. So your local cache, I can say. This is the big guy, so your DNS server. And let's say if you want to go to a URL, so your URL, right? And this is what you probably see when you are on Google, let's say in private mode, right? The color of the URL goes from blue to purple. Similar thing. It's in the cache. It knows where to go. Your URL you type in the local cache in your computer. It looks for the IP address. IP address to the URL if you have already went. If it is not there, goes to the DNS server and then look for it. What's that question, bro? One sec. YouTube takes its time to come up. You're censored hacker. JSKI Perplexity AI has security risks like hard-coded API keys and weak encryption that are very prone to data breaches. It's okay for quick research, but for struggles with coding, THM's tasks, Grok's better. Oh, I have to use Grok. I haven't used Grok. That's a good call. It's an ace at coding, 82.3% in code forces, great for THM networking like this, and very secure with SOC 2 certification. I would use Grok for safer learning. Ooh, that's a good recommendation. Thanks, bro. Let me mention that because I forget. Grok. But if you aren't giving any personal information, it's fine to use any. Yeah, I'm very careful with personal information. I agree. Add ChatGPT, and ChatGPT is not good for personal security as of May 13, 2025. It saves all data sent. Even deleted chats get saved in a secret folder. So if you got data breach, all your information. Yeah. ChatGPT I don't trust. Reason being, how I have seen because I knew about OpenAI before it was cool because of their experiment done by them, and Elon was around that time. But how I changed it, I don't trust ChatGPT. I agree. Saved forever for hackers to see. So far, Grok is the safest. Of course, brother. God bless you. Yeah, I know. It's interesting, and I don't know if it was sent to me by somebody my friend in Discord. You want to see a very beautiful video? And this is for everyone. This video is generationally good. And everybody watch this. Or maybe we can watch together on the weekend. But do watch this. Beautiful thing. So Slovakia, right? I think that's the country name, but I think Slovakia, right? This video, in this, they mentioned there is a company. I don't think a lot of people have heard about this company. It's called OpenBrain. Not OpenAI, OpenBrain. They created an Agent 1, which uses to go over like their own reiterate and AI making AI better, right? And that's the whole, and they talked about a paper in this video called AI 2027 and how fast AI is becoming better. Why I brought this video after you mentioned about the data breach. DeepSeek, right? How it made OpenAI was hacked, right? With the LLM OWASP thing mentioned by OpenAI that they were hacked by China and their data was leaked. They mentioned the same thing happened to OpenBrain. China hacked their system and got so much IP information. So I agree with you, and like I understand, and I will tell everyone, never post even a single information which can be like very disruptive or like any personal information on any of these chat rooms or anywhere on internet. Just do not push it. So thank you so much, bro, for bringing that out. Yes, I agree. Like never put any important information. I love that. I think I would love to start using Grok. I would love to. It's interesting, 100%. And I've heard good things about Grok. I don't know why I never got around it. But thank you. Thanks, bro. I love it. Love this discussion. It's cool. I will watch that, man. Oh, 100%. Thank you. Yeah. And I'll make this because I think that make it like this so people can see the whole chat too. Yeah. The caption should not be taking over the chat. Okay. This should be fine. Sweet. Yeah. And let's go back to our DNS. One day we should just look at all the Google, like all these AI, and come up with a good list of which AI to use for what thing, right? That'll be a cool, just a discussion or a Discord talk to do. Yeah, let's go over this now. As we were saying, right, your computer checks when you put a URL like Google, it checks if it is the IP address is already in the DNS or not, already in the local cache or not. If you have previously looked up the address, it will be. If not, recursive DNS server will be made. A request to your recursive DNS server will be made. So your DNS server basically will get this request, hey, what is the IP address of this URL? And this sent back to your computer. A recursive DNS server is eventually provided by your ISP, basically your internet provider like Shaw, Telus, Geo, T-Mobile, whoever. But you can also choose your own. This server also has a local cache of recently looked up domains. If a result is found locally, this is sent back to your computer and your request ends here. This is a common for popular and heavily requested services such as Google, Facebook, and Twitter. So basically, because these servers or these websites are asked a lot, those DNS server already have these URLs. But you want to type, let's say, personally my one, right, hackerspub.org, or a very let's say Indian government one, which is not used much in Canada. That's where it will be looking for that. If the request cannot be found locally, this case, right, India website or Sri Lanka website, a journey begins to find the correct answer, starting with the internet root DNS server. The internet's root DNS server. There are authorities that maintain those servers other than your ISP. The root servers act as a DNS backbone of the internet. Their job is to redirect you to correct domain, top level domain server by depending on your request. If, for example, you request TryHackMe.com, the root server will recognize the top level domain to be .com, refer you to that .com. So it will, just like we had this image, right? This image is a good example. Imagine these images as the servers itself. So this blue one, .com one, is a server itself, and information from this root domain server will go to .com and then will go to TryHackMe to find the right server IP address for you. And that's what is going to happen. As we see in TryHackMe case, right, goes to .com, right, top level domain, refer you to the correct TLD server, that means the .com server. The TLD server holds records for where to find the authoritative server to answer the DNS request. The authoritative server is often also known as the name server of the domain. For example, the name server for TryHackMe will be Cloudflare's, these ones. So, and this is what you will see again if you go to the dns.google and type your tryhackme.com, you will find these name servers. These servers have that information which we are looking for. You'll often find multiple name servers for a domain name to act as a backup in case one goes down. Majority of the time there are two. Some big ones have like 3 or 4. 4 is like I have seen 4 or 6 as max. An authoritative DNS server is the server that is responsible for storing the DNS record. Your TryHackMe, which IP address it should be. That's what we are talking. This name server will have that naming map. So authoritative name server, right, is the one responsible for DNS records for a particular domain name, where any update to your domain name DNS records would be made. Depending on the record type, the DNS record is then sent back to the recursive DNS server, where a local copy will be cached for future requests and then replayed back to original client that made the request, basically keeping it in cache. DNS records all have a TTL, time to live value. Like we saw 300, right, for R1 here. You see TTL 300. type is MX, and data. All have TTL value. This value is a number represented in second. That's the response should be saved for locally until you have to look it up again. So how often this information should be refreshed? Basically, a lot of time 300. This is in seconds, so 300 5 minutes is a good number. Some places they say, oh, put 60. Do not do that. There is no point. Caching saves on having to make a DNS request every time you communicate with the server. So every time you communicate, caching will happen. What field specifies how long a DNS record should be cached for? I would love to hear some answers, right? Like, I will read all these questions, try to answer, because if you want to learn, try to go back and try to remember these answers, or type it in the chat. It will be nice. What type of DNS server is usually provided by your ISP? What type of server holds all the records of a domain? This is your Cloudflare one, this is your ISP, and this is your record thing we saw. First one will be TTL, time to live. What type of DNS server by ISP is your reverse one? Reverse name one? Reverse? It's reverse, right? Recursive, sorry, not reverse, recursive. Recursive. And this one holds all the records. It's the name server DNS. Domain name server holds all the records for a domain. What is this one then? If it is not name server, TLD one, top level domain, no. Name. No. Okay, let's see. Authoritative. Okay. Wait, hold up. Authoritative server, also known as the name server. Okay, never mind. We were correct. Just the vocab got us. Okay, this is a practical. This will be good. Using the website on the right, you can build requests to make DNS queries and view the results. The websites will also show you the commands you need to run on your own computer if you wish to make the request yourself. Okay. And by the way, I'll send you this link. So if you want to play around with, let's say, YouTube or Google or anything, right? This is your go-to one. There are a lot of companies have their own DNS query ones, and you can make this query using basically your own command line. This is just a good one to easily look up. Okay. The website, basically we have to do ns lookup for this website.thm. That's your basically the one. DNS type, cname, blah, 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 subdomain. Okay. The website will also show you the command you will need to run on your own computer if you wish to make. Okay. So I want to find DNS queries view on the result. So I want to find cname, DNS type A, subdomain. So if I send for website.thp type A, I'll get these two IP addresses. Then let's say cname. Cname is the one server can't find this NX domain. Okay. Cname is for your domain itself. MX record. No authoritative answer, right? Non-authoritative answer. So this will be your mail address here. Let me hide myself for a quick second. So this will be your mail one, and the last one, text. Let's see what this says. Okay, here is the text, the data that is saved in the DNS records, and this is our flag. And these things actually you can just try it. This is actually NS lookup is a very commonly found one. Okay, some people are enjoying. What is the CNAME for the shop.website.com? Okay, CNAME for shop. I'll just have to type shop. CNAME basically where it will be going back or transferring to. Shops.myshopify.com. A lot of companies have this because Shopify is one easy way to set up. 1 second. Apologies, lads. Okay, what is the numerical priority of the MX record? Numerical priority 30 in the data, right? If there is a record with 1 as priority, that will be given higher priority. What is the IP address of a record? Here we go. The first one 10.10.10.10.10. Why 10.10? Look for this answer. Look for the understanding why not this. Why 10.10? Why? What is this 53? Look for that. Try to understand what this 53 is. Look, 43 here, 53 here is the port number. Try to understand what 53 is. I don't want to give the answer because I think it will help you understand what's going on. So why? One is 53, one is just the record. Sweet. So we are done here, right? And can anybody answer what is 53? What is 53? What is 53? Come on, lads. I would love to hear it. That means you're getting things, right? So, HTTP in detail. Let's see what HTTP is in detail. HTTP in detail. Learn about how you request content from web server using the HTTP protocol. What is HTTP and HTTPS? Request response, HTTP methods, status code, headers, cookies, and making request. Okay, we should be able to cover majority of this today. I just want to see what else is there. How the website works and putting it all together. Okay. This will consume some of your brain power, but it's good. Okay. What is HTTP? Hypertext Transfer Protocol. OSI layer number, 6, right? To standardize things. HTTP is what's used whenever you view a website. Developed by Sir Tim Berners-Lee. Sir should be there. I think he was knighted or he was given that title. So Sir Tim Berners-Lee and his team between 1989 and 1991. I don't know if you guys follow or how guys interested you are in the histories of tech, but he used a computer by Steve Jobs. Steve Jobs' second company, Next. Next was a company by Steve Jobs, and this was used by Sir Tim Berners-Lee to start the HTTP and the whole World Wide Web. Have a look into why Next happened and stuff. Interesting thing. HTTP is the set of rules used for communicating with the web servers for the transmitting of web page data and whether that is in HTML, images, videos, etc. So what type of media is being sent. And what's HTTPS? This is what you will see all the time in your website. Here, if I click, connection is secured. And if I go left, HTTPS. It's basically HTTP, but the secure version of HTTP. HTTPS data is encrypted so that not only it only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you are talking to the correct web server and not something impersonating. I think I can give you the name because the company is dead now. DigiNotar. This company, because these certificates, when you go to any website, if I'm going to Google, there is a certificate, connection is secured, there is a certificate that is valid, right? This company was the one that used to issue those certificates, but they got hacked and somebody Darknet Diaries has a beautiful episode in this. You can see it's purple. I've looked at this. They have this stuff, and I will post this here. This company got hacked. Somebody made bogus or fake certificates, and let's say if I make a bogus certificate of Google and put it on my server, if you go on google.com in a particular area, let's say Iran, India, Canada, everyone will go there and I can see what they're searching. They will be going to my Google, the one I set up, not the actual google.com. So that's why the company went bankrupt overnight, or closed basically overnight. So name the questions, answer the questions below. What does HTTP stand for? Hypertext Transfer Protocol. Do you guys know about these things which I talk about, like DigiNotar, or do you guys like it and stuff? Let me know, like, if you want me to like spend a little bit more time on these type of information I send, because that's how tech becomes interesting. And I will share my face because I forgot again. I'm not sharing it. Yeah, let me know if you want me to send put more information like DigiNotar and ask you these questions, because that's how you will understand what we are, where we are, right? And here, what is S secure? On the mock web page, or on the right, there is an issue. Once you have found it, right click on it. What's the challenge flag? So we have this website. There is an issue here. You see, it's not secure. An embedded page is there, which is technically not TryHackMe, right? It's not secure. So our flag is invalid HTTP certificate. So THM invalid certificate. And if you get an invalid certificate for a company's domain, that company is cooked. Or that company who gave that certificate, that is cooked. When we access a website, your browser will need to make requests to a web server for assets. Basically, assets is like the text file, the code file, the images, whatever it is, right? All those things are assets, right? To a web server for assets such as the HTML file, images, and download the responses on your web browser, right? This is downloaded on my web browser. Before that, you need to tell the browser specifically how and where to access these resources, which is where the URL will help. What this means is that the world, let's say the whole internet, is basically, as you saw, one server connected to other servers, and they further are connected to more servers or domains and stuff. Now imagine where you have seen this in your life, in your computer life. Let me give you answer. Folders. This is, let's say, your desktop folder. You have games. You have, let's say, images. You have text, right? Makes a Git. But you saw these things, and inside games you have, let's say, Vice City. You have San Andreas. You have GTA 5. Those type of game, right? Images, you will have, let's say, whatever, your images, blah, blah, blah. Same with the text files, right? Now, how do you access it? Like, if I'm in my, I don't want to show it, but if I'm in my Chrome or File Explorer, what I will do, desktop / games / Vice City to access that, right? Same idea goes with the internet. Because think about desktop, replace desktop with .com, right? Or this with TryHackMe, and this with the room on TryHackMe. And that's what you see. TryHackMe.com, the server. Inside the server, where I want to go, which folder? Room folder. Inside the room folder, which file I want to see? HTTP in detail. Isn't this the whole thing? Isn't this the whole thing? Your one server, server's address. Inside the server, there is the room folder. Inside the folder, there is a page called HTTP in detail. That's how this is. And that's the whole idea of unified resource locator, your URL. right? You don't have to remember this. I'd never remember uniform resource locator, but that's the idea of uniform or URL, right? Oh, that makes sense, right? That's awesome. I'm happy. Yay. My man, my man. I'm so happy you understand. I love that message. So if you use the internet, right, you have used a URL before. A URL is predominantly an instruction on how to access the resource on the internet. Basically, where the resource is, right? Awesome. I'm happy, man. It's making sense. And that this is the whole idea, right? Where this resource is on the internet. You tell the server where and inside the server. Same with your profile. If you want to go, this is exactly how it is, right? The below images show what a URL looks like and all its features. It does not use features in every request, all these, but this is a common way, right? This image is not that good. Let's see. Okay, good. Here, now you can see, beautiful. HTTP, the type of protocol, the type of scheme. Do you want HTTP? Do you want HTTPS? Do you want FTP? Right? Which type of protocol I want? Then user and password. Sometimes you need it, sometimes you don't. This is probably you have seen with SSH or VNC. When you, let's say if you go on any TryHackMe server, I will show you a beautiful way to see this. You will have seen this, you would not have even realized this was a thing. Okay, here we have. I start this machine. See how beautifully this opens up in 30 seconds. And you would have seen this, you'd never even realized. Okay, so going back, right? We have first what type of scheme or what type of protocol we want, because protocol helps us tell what we are going to do or how we are accessing it, right? Then username and password if required. A lot of time username password is saved in a different way, so you don't need it. Domain name like facebook.com, you don't need your username password for facebook.com in the URL, right? Host, port, right? A lot of time if you are doing local development, you change this port from 80 to let's say 8080 or 1234. Path, which room, which folder, right? And something extra information like query or fragment, right? Fragment is when, let's say if I'm on, best example here is for GitHub. Let's say if I'm going on Metasploit. Check this out. Let me open README. Where is README? MNOPRE, README. See this. If I go here, there's a link here, right? What is saying? Let's see. Let's see this link. You see this IP address or this information here? GitHub.com Rapid7 organization, right? Again, folder. Inside that organization, which folder? Metasploit framework. Blob is just the information. Master is the branch. README is the file. We opened README, right? We opened README. Hashtag, right? Fragment is installing Metasploit. Where did we picked up from? Installing Metasploit. And this is your tag. Oh, thanks, bro. Yeah, I'm a front-end developer. I check so many things every day. So that's awesome. Thank you for saying that. Thanks. I love you. I love you, man. This is so awesome. But yeah, this is how it is. And now see this interesting thing. Our machine is here, right? Our machine is here. 1 minute. Oh, start attack box. Our machine is here. I can terminate this because this is actually a... But actually here you can see this as well. Now I will open this machine attack box in full screen. See the URL. Here we go. What we are doing, we are telling VNC attached to this VNC server. It's technically giving me a server and giving me all the extra information. What is the IP address of this? Resize, extra information, password is there sometimes, right? The username is given sometimes. So a lot of time URL might give you so much information, you can technically hack a website. That's how the game is. And this information, I can change this IP address. I can change remote to resize to remote. Instead of remote, I can change something else. I can change the password. Let's say if there was a username and password in this, right? Here is go. And this is what happens. This is a hack, right? If username and password, I can start brute forcing this username and password and might find somebody else's password. Oh, awesome. Thanks, man. Love you too. Love you too. Love you. But yeah, like this is how it is, right? Sometimes you find, you don't have to, that's why it's important to create like a whole list of things you want to check when you're going for bug bounty hunting. So you don't miss something which is very usual. And that's why a lot of people who are starting in bug bounty are able to find these hacks, because for them it's a very important thing. But for an experienced person, like even for me, I will miss this out. I won't even see the URL, because a person like me, I will like, oh, there won't be anything username or password. Who does that? Somebody might have on some place, right? So with that being said, now you understand scheme is the protocol. This instructs what protocol to use, right? HTTP, HTTPS, file transfer protocol, right? FileZilla if you're using someone's. User, some servers require authentication to log in. You can put username and password. That's what you do with the SSH, right? Host, the IP address you can give, the domain name you can give, whichever. Then we have the port. Sometimes when you do Nmap, you change the port, right? From 80 to let's say 8081 or 8080 or 443 for HTTPS. It can have value from 1 to 65535. Path, the file name or location of the resources you are trying to access. Basically which room in TryHackMe, right? Or which image on the server. And this is what you see actually. Let me show you on Twitch. Twitch, which file you are accessing here. You are accessing me, my domain or my name, right? You're accessing me here. Now I can just change the name from this to, let's say, what is his? Ludwig is my favorite. Ludwig, like maybe Ludwig. I don't even have to search. I went to his one. Pretty cool, right? The guy is amazing. He's amazing. I love him. But yeah, that's how easy it is to go. Okay, with that much time spent on this, let's look forward. Query string, this is extra information sometimes some web servers require. So you can tell them, let's say blog ID. I can give one. It could be blog, then ID 1 to give me the blog number 1, blog number 2, blah, blah, blah. Fragment, this refers to a location on the actual page. Just like in our case, actual page on this location is installing Metasploit, right? And that's how this is actual information on that particular page. This is commonly used for pages with long content and can have a certain part of the page directly linked to, so it's viewable to the user as soon as they access the page. So if somebody just wants to go on install, this is a better URL instead of them finding readme.com, readme.md file and scrolling down, right? Making a request. It's possible to make a request to a web server with just one line, get HTTP1. So making requests, this is what we'll see. Amazing thing. And you will see through command line as well if you get a chance. The request method, which is get. Protocol, there are HTTP, just like, ChatGPT has multiple versions, right? iOS has multiple versions. HTTP also has multiple versions. It's a protocol. It's a software. It is, if it becomes better, more secure, there will be more versions. So here we are defining 1.1 version and the page is being requested. But for a much richer web experience, you will need to send other data as well. This other data is sent via what is called headers. where headers contain extra information to give the web server you are communicating with, but you will go over more into about headers in the headers task. I will show you headers, how to see, and basically you are using that, and I will show you how to use that if you're using web browser right now. I will show you when we reach there. So example request will be get HTTP1. Here is the thing, get method. What do you want to get? This, on this server, I want to get the home, the root directory. On TryHackMe, it will be room HTTP in detail, right? And what protocol I want to use. Host, what is the URL or the server. User agent, basically which browser I'm using. Referrer, basic the whole full HTML, I guess that's the name. One sec. Yeah. To break down each line of this request, line 1, this request is sending the get method. Wait, what's it? I have to go eat, brother. When I am done, if you are still alive. Oh yeah, 100%. Love you too, bro. Great live, and God bless you all. 100%. God bless you too, brother. Galatians 6:9. I think chapter 6, phrase 9, something, right? I'm not sure. So let's see. Oh, do not grow weary of doing good. Nice. I love that. Have a good one, brother. Love you. Have a great day and enjoy your meal, right? And do not forget to join the Discord, everyone. Like, that's the best way. Like, you can reach out to me. Great community if you learn about cybersecurity, right? So, love you. See you soon, brother. And thank you for joining. Thank you. So yes, I'll save this. Actually, I want to bookmark this. I like it. But yeah, I'll close the Metasploit. Close this. But yeah, as you were saying, to break down each line of this request, we have line 1. This request is sending get method. More of this in the HTTP header task. Request of the home page, the root page, and sending this web server and basically telling the web server we are using HTTP protocol version 1.1. Line 2, we tell the web server the website, basically which website. We tell the web server in line 3 which browser we are using. Line 4, we are telling the web server that the web page that is referred to is this. So basically which root page from which URL. And last, line 5, HTTP request always end up with a blank line to inform the web server the request is finished. So here, after this is also a line which is blank. So example response will be this. HTTP1 200 OK. 200 means everything went well. Here is your answer. Server, what is the software of this web server itself? The date and time when the request was finished. Content type, text HTML, it could be a form, it could be an image, it could be a video, depends, right? Content length, how big is the page? So it is, all the characters if you include will be HTML, head, and all this information. And if you see there's a gap, so extra information, all this other information that you don't see on the web browser or your web page, right? That ends here, and this one is the starting, and there will be another space at the end. To break down each line, line 1, again HTTP version 1, right, 1.1, the protocol that is being used, and that's followed by the HTTP status code 200. There are multiple status codes. What you need, and you have seen it, 404, right, not found. That's the status code. Hey, I did not find what you were requesting. There is 404, there is 301, 302, 200 OK. Then there is 500, which is internal server error. You just, as a web person, it's important, or even as a hacker, you need to understand like 5-6 of these. You need to have them on your tip. 301, 302, 400, 404, 500, 501 or 2 is also important, and then 200. Okay. Good when you're using Nmap and GoBuster. So here, this tells us that the request was completed successfully, this 200 OK. And if you can see this information, when you go on inspect and click on the network tab, I'll show you here. All these requests are being made to the TryHackMe server, and you can see so many. Some is 101, which is switching the protocol. There are 204. There is 304, right? Modified, not modified. There are various codes, but you need to know is 200. And let's say if I go to HTML in detail test, see, so many other requests were sent, which is like 304 and other stuff. Probably it got redirected to, right? Because it did not find anything, it redirected me to this page, not found, 404. And that's how things work. That's how your web browser knows it found the request or not. And you can see all this information, and when you go a bit more depth into web browser and bug bounty hunting and web hunting, your network tab and source tab will be your best friend, and also the console. Okay, so with that, the line 2, this one is space, tells the web server in the line 2, the Nginx one, server 1, tells the web server software, Nginx is the server software and the version, helpful to find if, let's say, I know there is a hack for this one. If this is the old one, I will look for a hack for Nginx, which is with this version. Current date, time and the time zone, right? Content type headers tells the client what sort of information is going to be sent. HTML, images, videos, what type of information, right? Content type tells the client how long the response is. This way we can confirm no data is missing. So we have this 98. So you know all these together, this information should be 98 characters total, including spaces. I believe. Yeah, it should be including spaces. HTTP response contains a blank line to confirm the end of the HTTP response. Here at the end. Here at the end of the information. The information has been requested is this, the home page. Welcome to TryHackMe and the title. Okay. Answer the questions below. What HTTP protocol is being used in the above example? What is it? HTTP 1.1, right? /1.1. What response headers tells the browser how much data to expect? Which response header? Content length. And once, I don't know if you guys have gone through Burp Suite, but in Burp Suite, you will see this information so much. Okay. So this one is a small one. Let's cover this. So HTTP methods, right? There are 4 types of methods mostly. Actually, they have increased it if I'm not wrong. Let's see. They were talking about to increase it, right? Now, yeah, there is trace, there is head, there is patch, a bunch of them. But what you as a person should be looking for, right? As you have to remember are these 4 ones, because this is what as a developer, as a hacker, you will be using mostly or interacting with Burp Suite specifically or with Postman. HTTP methods are a way for a client to show their intent action. So this is a way for me to tell to TryHackMe server what I want to do. When making an HTTP request, when I'm clicking a button, when I'm doing something, let's say I want to get what my profile looks like, or get my image or my profile image, or I want to delete my server or my account, all those type of intent. There's a lot of HTTP methods, but we'll cover the most common ones, although mostly you will deal with get and post. Not really, but yes, kind of get and post will be, but depending, some places you are just using put or delete. But get is basically getting information. Let's say in case of Facebook, right? You want to get the your profile, your timeline, right? That's how it is. Post, you are updating, you are changing, right? Creating a new record, you are adding a new post, you are creating a new post, right? That's one. Like for example, if you type a comment right now, you are adding a new comment, you are posting something, right? And that's why it's called posting, because you are posting a request. Put is changing. You are updating the information, like you are updating what's called your profile name. You are updating your post. That's a put request. Delete, you are deleting a post on your Facebook. That's what delete request. So all that is like the four major ones. And mostly, yes, you will be going with post and get, but a lot of places put is used a lot. What method should be used to create a new user account? I would love to hear some answers, so I'll just read through these, right, and give these answers so I know you are getting something, right? Here, a new user account, what will be the method? To update an email address, what should be the method? To remove, basically delete something, what should be the method? And to view something, what should be the method, right? Hopefully, you guys have the answers. So first is creating something new. You are posting, let's say posting a post, a new image on your Instagram or Facebook. I want to update my email, right? Put. These are basically verbs. Except for put, others are basically verbs, right? I want to remove, I want to delete something. What method should be for viewing? I want to get what image it is. I want to view my image, I want to get my image. Okay. So we have these status codes. Let's take this tomorrow. Do you guys want me to take it right now, or do you want me to take it tomorrow? What's your guys' call? I would love to hear, or whatever you guys want. I can do it. I can take care of this today, or if it was a lot of information, I can do it tomorrow. What's your call, lads? Anything you like me to do? If no answers, I will probably go off today because my throat is hurting. But I can still go for this. If not, right, let's plan for tomorrow. Tomorrow we'll cover task 4. What are the status codes? Why status codes are important? Because let's say if you are doing with GoBuster or DirBuster. I will say GoBuster because faster and has more. GoBuster responses. I'll show you something you will see all the time, right? Open image, new tab. So if you run GoBuster in your server, right? This is the server you want to attack and stuff. You see this important one here has a status of 301. Do you understand the meaning of 301, right? What is that? Those type of information is important. That's the type of information now you want to see so you can make. And GoBuster makes a, what type of method it use? Get method, right? What type of HTTP method it's asking, right? So these type of things are important. That's the reason it's important to know these type of codes, what's going on, what are the URLs. If this is a good example again, probably to see here, beautiful example. So I want to hack this website. I'm using the get. You see the methods here. For different methods, I'm using different. There are 403, 301, 200, and all those. Now I know 403 I don't have access, but okay, 403 there is no need, right, to check. But APIs I can get. So this type of information we will be talking about tomorrow, and that's why I will be focusing on the status code a bit more. I want you to go home, learn what we did, so we can talk about the status code. What are their information, right? So that at least when you just look at the first number, you know what's going on. Then headers. Headers are the extra information you will see. I will show you the burp suite, how things work, because you need to understand what these information means so you can manipulate it to send to a server. With that manipulation, you might be able to get extra information from that server. That's one. Cookies. You need to understand cookies if you want to understand how hackers hack your data, how they will be able to access your Amazon account, your XYZ account without you knowing, right? These cookies are important. As a developer, you need to understand cookies. Last, making a request, which is a practical. So we'll talk about this. This will be a beautiful one to talk. And we will also talk about how the websites work. Because if we already know how the HTTP is, let's talk about also how the websites work. And okay, why it's not coming? Excusez-moi. Come on, load. How the websites work. This will be request response. This is all about architecture. HTML is beautiful. I can show you some interesting thing with HTML. JavaScript, I will show you some amazing stuff because I am a developer of JavaScript and React. Sensitive data exposure and HTML injection. This will be fun. We'll do some actual hacking in this real world. Some real world actual HTML injection hacking. So that'll be fun. 100% will cover how websites work and putting it all together. Okay, so putting it all together will be how all the information we grabbed from 1, 2, and 3 can work. So probably we can cover all this. So tomorrow, beautiful thing, we'll cover how the web works. So do join this so that for our pre-security path, we will cover a big major chunk. And Linux is my favorite. We'll hit it so hard. We'll cover a lot. So thank you everyone for joining, right? Let me know again, this is the Discord. What I won't ask you to like, share, subscribe. Oh, thank you for all this. Oh, thank you. Yeah, one thing I would love to ask you guys, right? Because like you see the captions here, somebody requested this. So if you can join the Discord and let me know how I can improve, how I can deliver better, what I can do to provide better education to everyone, that will be amazing if you guys can do that for me. I'm sending my Discord in the link. Feel free to let me know how I can improve, what else I can do, what topics we want me to cover, whether it's about hacking, coding, AI, resume. I'm building my resume blog. I forgot about it in the middle, but that will be sent soon. So if these type of things you want to talk, I would love to help you, even about life, right? As an immigrant, I have seen some ups and downs in life. So hopefully, if you have any questions and I can help you, I would love to. But till then, thank you so much, everyone. Do pay it forward, help others, educate yourself and educate others, help others get information and study, because education is the only way to get out of these classes and these social classes, right? And get a better life and make other people around you happier, better, brighter. So just that, right? Pay it forward. Don't even be scared of asking for help, and have a great day. Love you all. Thank you for all the messages, and I will see you tomorrow. Till then, again 7 p.m. PST. Till then, thank you so much. Have a great night and bye. Bye everyone. Have a good day. Love you. Thank you.